Welcome to the Master of the NEC podcast, the ultimate destination for anyone passionate about the electrical trade. Whether you're a seasoned electrician, an eager apprentice, or just someone who wants to dive deep into the world of electrical work, you've come to the right place. Join your host, Paul Abernathy, a true authority in the industry with over 38 years of trade experience, as he electrifies your mind with in-depth discussions, expert tips, and valuable insights that will keep you ahead of the curve. Each episode, Paul will illuminate the complexities of the trade, decode the National Electrical Code, and share the latest industry trends, all while empowering you to take your electrical career to the next level. So, gear up, plug in, and get ready to supercharge your knowledge, because with the Master of the NEC podcast, the power is in your hands. Now get ready. Here is your host, Paul Abernathy.
What up, everybody? Welcome to another episode of Master the NEC. My name is Paul Abernathy, your host, as always. Look, if you're trying to learn the National Electrical Code, this is not an easy document to learn. We're going to be talking about a change in the 2026 edition of the National Electrical Code. But if you're somebody out there that wants to get a really important resource in your pocket, then I'm going to tell you about our Mastering the NEC course. It's not for exam prep. It's just for everybody who wants to learn the NEC a little better and have a resource in your pocket that doesn't expire. You can go to it and look at it at any time. You can look at illustrations, graphics. That is on our website, fasttracksystem.com, and it's called Mastering the NEC. Now, of course, if you're studying for an electrical exam, you want to use our basic or our enhanced program. But if you already are licensed and you just want to learn the NEC better, then what you want to do is you most certainly want to look at our Mastering the NEC course. And it is basically like a perpetual resource in your pocket that you can turn to, look at illustrations, graphics, and it also includes our Fast Tracks Enhanced. It means if you're in the field, you're looking at something, you go to the course and you look at it and you still don't understand it, then you can put it in the interactive chat feature and it sits there and we'll go in and answer it and we can have some discussions back and forth. But again, you can't really put a price on that. That's like having a consultant in your pocket. And that's what Mastering the NEC. So it's not always about exam prep. If you want to get a course that's basically in your pocket resource, then you want to look at our Mastering the NEC. Okay, so check that out on our website, fasttracksystem.com. The link will be down in the description. Check it out. We'd love to have you as part of the Fast Tracks family and moving forward. So again, we're not just about exam prep. And of course, we have grounding and bonding courses as well if you really want to learn grounding and bonding. And that is a good segue into today's episode here at Mastering the NEC podcast. So we're going to be talking about the change in the 2026 edition for 250.122, which is a sizing of an equipment grounding conductor. Now, this change I think is significant. Obviously, everybody knows my history on this and my disagreement with what the code panel did. But I'm going to put that aside and do my job as an educator. It's published. It's out there now. I can disagree with it, but I'm not going to talk sour grapes. I'm also hoping that nobody ever gets hurt with this change. Okay, so I'm going to be very positive thinking and just kind of tell you what has changed for the 2026 edition of the National Electrical Code when it comes to 250.122 for equipment grounding conductors. Okay, all right, so I'm going to kind of talk you through it, give you this mental picture as you're going, maybe you're listening in your vehicle or on a job site or whatever. You got your earbuds in, you're kind of moving along, plugging along, and you just want to listen to the changes. Y'all know that when we size the overcurrent protected device for a circuit, that the circuit that it's protecting has an equipment grounding conductor. Now, 250.118 could allow that to be a raceway, like an EMT, a rigid, intermediate. Okay, we have these different options. If you're using the wire type equipment grounding conductor, then we are dictated in size based on that overcurrent protected device. And where do we go? We go to 250.122. Now, in 250.122, there was an effort here in Code Making Panel 5 to kind of simplify the language, make it easier to read and more easier to apply. It kind of went a different direction than I thought it should have gone, but it did what it did, And so that's what we're talking about today. So I'm going to kind of read this to you, and then I'm going to explain it to you. This is going to be one that you don't necessarily have to be sitting in front of your code book to kind of get, because as an electrician, you should know that I'm sizing that equipment grounding conductor based on the overcurrent protected device. Now, and you buy a cable assembly, then you have to rely on the manufacturer to size that equipment grounding conductor. And we have different standards that we utilize that's going to dictate the minimum sizes. For example, for SE cable, we're going to use 854. It's a UL standard. It's going to tell us the minimum sizes. We're going to have non-metallic sheath cable. It's going to tell us the minimum sizes. So we, as a manufacturer of wire and cable, many things have to work in step with the National Electrical Code, okay? They work together. Now, we also understand that there are allowances in the NEC where you could have a certain ampacity and you go to the next standard size overcurrent protected device to protect it, and that's going to dictate the size of the equipment ground. We have different rules that we have to be aware of, and that's, again, I always to say that's why electricians get the big bucks, because they have to worry about all these little rules that we have to follow. But at the end of the day, manufacturers do a good job of making sure that the conductors are sized right. Now, where does that go astray? And I'm sure you all are already thinking this and are familiar with this. Where can this go wrong? And that is when people take a tray cable, take an MC cable, and they parallel it. And the reason they're paralleling it is to get more sets per phase or more sets per line in order to increase the amount of current per set. Okay, and set's going to be anything over one. Okay, set of 2, set of 3, set of 4. You have one. You don't have a set. You just have ones. So anyway, so we're doing it because we want to take the hot conductor and have multiple sets of it. That's going to give us more current carrying ability. They go together at each end. That's their paralleling rules, and they go together and they act as one. And that way, I can get more current out of it. Well, we can't do that to the equipment grounding conductor. We can do that to the hot, ungrounded conductor. We can do that to the neutral or grounded conductor, but we cannot do that to the equipment ground. So traditionally, we have to say, well, what is the overcurrent device you're working with? This is the overcurrent device. We're going to go to 250.122. We're going to go to the table. We're going to select the minimum size of the equipment grounded conductor, knowing that we could go larger if we want. And there are going to be some cases that you may go larger, but at the end of the day, that's a minimum size that we have to have based on that overcurrent protected device, okay? So here's what it says starting out in 250.122. I'm going to read it to you because I think it's important that we bring context to it by reading it, and then we can discuss it. It says, copper, aluminum, or copper-clad aluminum equipment grounding conductors, or EGCs, of the wire type shall not be smaller than shown in table 250.122 unless otherwise permitted by 250.122A through 250.122I. Okay, so these are minimum sizing requirements, but there may be some other allowances that you can follow. But this is a general rule. All right, we're following the general rule. So for example, if I go to this table and you look at the left column, it's going to be the overcurrent protected device. It is a 60 amp overcurrent protected device. The equipment grounded conductor, if copper, is going to be a 10 gauge. If it's aluminum, it's going to be an 8 gauge. Pretty straightforward. Okay. Now, one thing that I always tend to have to explain to people that, and usually if you've done this for a while, you don't have this confusion. But when they look at this, they see, well, wait a minute, how come it goes from 60 to 100? What if I have a 70 amp overcurrent device? What if I have an 80 amp overcurrent device? Where do I fall? Well, remember, if it's over 60, because if it's 60, it's a 10 gauge equipment ground. If it's over 60 up to 100, then you have to jump up into the size for the 100. So it'd be an 8 gauge. So anything 61, I'm just throwing numbers, 61 and higher up to 100, the equipment ground would be 8 gauge. Now, of course, y'all all know that the standard size overcurrent protected devices are in 240.6, okay? And so when you go look at that, you'll say, okay, that's the standard sizing. And so, for example, a 70 amp, let's say, it would still require it to be an 8 copper equipment grounding conductor. Even though you don't see 70, for example, I'm just throwing a number, you don't see it on the table, okay? You don't see 80 on the table, Okay. You don't see 90 on the table. Okay. It jumps from 60 to 100. So remember, when you get over 60, you just defer to whatever the 100 would be. Make sense? Okay. Same way if you have 150 and you notice it jumps from 100 to 200 at the table, 250, 122, then you're just, if it's over 100, you're going to use whatever the minimum equipment grounding conductor size is based on the 200, because that picks up the gap over 100 all the way up to 200. Y'all get that. And I know y'all know how to do that. And again, I only say this because I do see from time to time on social media and things that people don't get it. And so I just like to reiterate it and make sure that everybody's clear on it. So again, going down the road, you teach somebody else, and in that nature, you're propagating truth. You're not propagating falsehoods or fictitious things that I typically see on social media. Okay. All right. So now we're following this table, but then it says, unless otherwise permitted in 251.22a through I. All right. So now we got to go down and look at each one of these. So let's get to the very first one. Let's look at A. A is saying, now this is the one that I argued until I was blue in the face. Okay. Blue in the freaking face. Because when you got down to multiple conductors and paralleling, it referred you back to A. And the old language of the A said an equipment grounding conductor shall not be required to be larger than the circuit conductors, and it had a plural, an S. Circuit conductors supplying the equipment. So for years, forever, for eons, if I have multiple sets and they connect together in parallel at each end to a piece of equipment, maybe 3 A's, 3 B's, 3 C's, whatever, that all the A's together was the circuit conductor for phase A, if we're talking 3-phase. Same with B, same with C. So the equipment grounding conductor never needed to be larger than the circuit conductors supplying the equipment. In my mind, in many people's mind, and educators and Augusta Soars forever said, you know what? The reason we're paralleling is to make them act as one. Those are the circuit conductors. So if I had, I don't know, I said 3,500 kc mills, then that was 1,500,000 circular mills. So my equipment ground could be larger than what the table dictated, but it never had to be larger than the service conductors, or it's not service, circuit conductors. So that is an occasion where you might have an overcurrent protected device that's large. You have more parallel sets that could be smaller because you're paralleling them out to get, get more current with smaller conductors. That's the whole reason we parallel. And ultimately, you could have had an equipment ground in there that was larger than the largest circuit conductor in that raceway, because we're paralleling. Anyway, that sounds confusing. Don't worry, because they decided that that's not what we want to go now. Okay, so let's simplify it. Let's make it clear. A says not larger than the circuit conductors. So EGC shall not be required to be larger than the circuit conductor supplying the equipment. Okay, that's it. I would, and so we won't even get into parallels here, because now when you go down to look at H, when you have conductors in parallel, it is basically making it, I don't know how to say this. It's making it irrelevant to go back to A for this at a point. Okay. And their intent was it never has to be larger than the largest ungrounded conductor in the circuit. Okay. Anyway, so that's the rule. It says, so EGCs are not required to be larger than the circuit conductor supplying the equipment. Boom. Done. Next, other than wire type EGCs. Okay. So this is saying, okay, we were talking about wire type. Now we're saying, okay, well, cable trays, raceways, probably should have said, well, raceways are going to cover everything, to EMT, all that's just going to cover all that. And again, all those wiring methods or all the things that can be an equipment ground conductor are listed in 250.118 anyway. But it just goes on to say, other than the wire type, cable trays, raceways, cable armors, and sheath used as EGCs as provided in 250.118a, that's the list, and 250.134a shall comply with 250.4a5 or 250.4b4. So it's going to provide a low impedance effective ground fault current path, meet all the performance and prescriptive requirements that we were going to see with 250.4 plus everything after that. So it's going to work together in harmony. That's what it's saying. And again, not all cable trays can be used as an equipment ground. And if they are, there's going to be other provisions that you have to follow. So just keep that in mind. So it's not a blanket statement. Just keep that in mind. Next is sectioned equipment grounds. EGC shall be permitted to be sectioned within multi-conductor cables if the combined circular mill area complies with 250.122, the table. What that means is a lot of variable frequency drive applications or whatnot will actually section out their equipment ground. So it is the proper size. It's just divided by 3 and it's inside of the cable in 3 separate locations. If you added the circular mill up together, it would be equal to what's required by table 251.22. But it's been sectioned out for whatever reason. So it could be for a specific application, for example, variable frequency drive applications or whatever. It is permitted to do it. Not all manufacturers do it. And it's not typically something that's done on normal, like a tray cable and things like that, or a MC cable. But they do have the ability to section it out like that. Again, as long as the combined circular mill is the size that it would be required if I installed just one in the cable. That's okay to do that if a manufacturer wants to do that. D says increased in size. What are we talking about here? All right, it says if ungrounded conductors are increased in size for any reason other than as required in 310.15b or c, and these are adjustment and corrective. So any other reason other than for normal adjustment or corrective purposes, like more than 3 current conductors, or where you're sizing it due to the ambient temperature that's other than 30 degrees Celsius, 86 degrees Fahrenheit, any other condition or any other reason other than those that you happen to just increase the size of the ungrounded conductor, in the most common one that we all hear about is voltage drop, which, by the way, is not mandated into the code, except it's mandated in things like sensitive electronic equipment and fire pump applications. But anywhere else, it is just good design practice, right? But in any reason that an engineer, for some reason, wants to bump up the size of these ungrounded conductors, and it's not because of the number of current conductors, or it's not because of the ambient temperature issue, then you're going to have to increase the size of the equipment ground proportionally, okay? So if it's a wire type, if installed, shall be increased in size proportionally to the increase of circular mill area of the ungrounded conductor. So you're going to have a normal size equipment ground that would be required for that circuit in normal, and you're going to start, that's your starting base. They increased the ungrounded conductors because, let's just say, voltage dropped. So it went from, say, 250s up to 500 kc mils because of the distance. Okay. Right. So this wasn't for 310.15b or 310.15c. It wasn't for adjustment of correction or ambient temperature. It wasn't for that. So they increased it. So in this case, I have to look at what the old size was that would normally be protected by that overcurrent device, that would normally still have to be protected, and I'm increasing it in size. Still may be the same size overcurrent device. They're only increasing the conductors in size because of voltage drop. Not because of more current being drawn, but because of voltage drop. Okay, I get you. But by doing that, now we have to increase the size of the equipment grounding conductor proportionally. Okay? And I will remind you that there is an example of this in the NEC back in Informative Annex D, in case you get confused. And also, I think, and I might recant that statement, I think there's one in D. But if you're in the handbook, or you happen to be in the link, there is a good example of how to do that. Okay, it's not brain surgery. Okay, so the ratio is a pretty easy calculation. But at the end of the day, you could have to increase it. Now, there is an exception. The exception says, well, EGC shall be permitted to be sized by a qualified person to provide an effective ground fault current path in accordance with 250.4A5 or 250.4B4. Again, still have to produce that effective ground fault current path. What this means is that somebody, a qualified person, years ago, we tried to get this to be specific to like an engineer or design professional, but who is the qualified person? Well, we can argue at this point that you're the electrician, you're licensed, you've been doing this, that you're probably the qualified person. I know they'd like that to be otherwise, But reality is, I'd argue that point. You are the qualified person. You're the one installing it. And if you want to say, no, I don't want to increase the size, even though I went up in size, that I think that the current equipment ground can handle it, that's fine. But you are going to have to be the one that takes the ownership of that and presents it to the AHJ, and the AHJ is going to have to accept that. And you become the qualified person. If something happens and that overcurrent protected device does not clear, okay, because you've got the conductors that were increased in size, so their impedance is less, and the fault is more magnitude out, and for some reason it bottlenecks the return back on the ground fault path. Let's say the effective low impedance ground fault current path, say it wasn't adequate because you didn't increase it in size proportionally. Let's just say it happens, and you did not increase it in size based on this rule, you're responsible. Most electricians aren't going to do this. Most electricians go say, look, I'm not going on the hook for this. If you increase the conductors for any reason other than what we talked about, then I'm going to be increasing that equipment ground too. Now, the reason that's important because you get wire that is inside of a cable assembly that's already pre-made. That equipment ground is not going to be increased in size. So if you're running a cable assembly that has a predetermined size equipment grounding conductor based on a UL standard for that cable, it doesn't necessarily mean that you're going to comply with this if you do increase it in size. It doesn't necessarily mean it's going to equate. You get me? Now you might get lucky. You go to a bigger MC cable or a bigger tray cable and it's a bigger equipment ground. But again, you saw that gap between the 60 to 100. So it just may not be larger. So you could fall in that realm. So I just say, be cautious, be careful. Not going to be an issue probably. Now, if you're running EMT, rigid, intermediate, you don't have to worry about it because that wiring method itself is an equipment ground. However, I'm going to tell you something that if you do install it, even though you're saying to yourself, well, it's redundant, I've already got the wiring method qualifies, that's not going to work because of the language. Did you see what it said? It says wire type EGCs if installed. Doesn't mean that you have to. I mean, I can use EMT, rigid, intermediate, and use the raceway. That's fine. But if I install the wire type, and most engineers will do it, then I have to meet all these rules. I can't just say, well, shit, I can let the wire type equipment be smaller because I've already got the wiring method that qualifies. So it's just a little extra. It's not how it works. Just so you know, you're going to have to be full size EGC as well. And if you increase it, you have to increase it proportionally. Okay, keep that in mind. The next one is E is multiple circuits. So if I have a wiring method, like let's say I have a raceway or a tray or a trench or cable tray, whatever, and I'm putting in there multiple circuits. So I have, multiple hots, multiple neutrals. I have multiple circuits in one single raceway. And assuming again we're meeting raceway fill requirements and yada yada yada, we're looking at more than 3 current carrying conductors. Again, that's a given. I should not have to repeat that to you folks because you should know that. So I don't want to kind of go backwards down the hill when we're trying to learn. We're just talking multiple circuits. Okay, 3 separate motors using one raceway to take the circuits to get to it. You get me? The code says that I can have a single EGC in that raceway that could satisfy the equipment grounding conductor requirements for all of those circuits if it is sized from table 250.122. And it has to be sized based on the largest overcurrent protected device protecting the conductors in those raceways, cables, trenches, cable trays, whatnot. Okay? So if I have 3 circuits and one is 150 amp, one's 100 amp, and one's 80 amp, then my EGC, my equipment grounding conductor, has to be sized based on the 150. Not the 100, not the 80. The larger. Now, when it gets to a common junction box, let's say the circuits, one's going to go off that way, one's going to go off to the right, to the left, and one's going to continue straight. Then I can drop down to the adequate size for that circuit that's feeding that specific piece of equipment, but not in the portion that's running out to the junction box. That has to be full size, okay? Based on the largest overcurrent device. You with me? Okay. Now, EGCs installed in cable trays shall meet the minimum requirements in 392.10b1c. That's also reminding you that your equipment grounded conductors in a cable tray can be as small as 4, but you still have to follow all the rules, right? We just can't assume anything other than that. All that is saying that single conductors that are used as equipment grounded conductors shall be insulated, covered, or bare, and they shall be 4 or larger. That's all that statement was saying. Okay, so don't let any of that, if you don't go look that up, don't let any of that confuse you, because that's really no need for any confusion. Okay, unless, of course, again, we're talking about if the cable tray itself qualifies, okay, then that's a different story. If the tray qualifies, right? Okay, let's get into the next one, which is the motors. Now, motors circuits, and that is F, it says EGCs for motor circuits shall be sized in accordance with 250.122F1 or 250.122F2. Again, this is just a good example of me stating the and or. So it can be sized based on 250.122F1 to the motor. That is a general rule, and I'll read it. And then F2 is basically saying, well, what if it's an instantaneous trip circuit breaker or a motor short circuit protector? Then I've got different allowances. Now, I'm going to tell you, for the vast majority of people that run these circuits to motors, they follow F1. And F1 is general, and it says the EGC shall not be smaller than determined by table 250.122 based on the rating of the branch circuit, short circuit, ground fault protected device. Okay, so that's 430.52. And that's where you would see that. Okay. So you go there, and whatever that overcurrent device, and again, that's like a circuit breaker, that could be up to 250% of the FLC, right? And whatever that puts you at, which is the branch circuit, short circuit, and ground fault protected device, which, for all intents and purposes, that's the overcurrent protected device, by the way. Okay, just in case the only difference in here is doing short circuit and ground fault. It's not necessarily worrying about overload, because the motors themselves are going to require overload protection. Okay, so a lot of people get confused with that. They say branch circuit, short circuit, and ground fault protection. Is that special device? No, it's the same circuit breaker, let's say. It's just that we're not worried about the overload. We're worried about short circuit and ground fault. And remember, there's a difference between the terminologies overload, short circuit, ground fault, are all part of what we call overcurrent, because all of those things can create an overcurrent event, right? So when we say overcurrent protected device, we're protecting from short circuit, ground fault, overload. That's why when it says here, short circuit and ground fault, that's the only two elements that it's keying in on, okay? It's not so much going to protect any overload. Now, it doesn't mean it possibly can't. There's a scheme that you can achieve that for motors, but generally, we're not worried about the overload part. That's a separate thing, okay? Now, F2 is talking again about instantaneous trip circuit breakers, if that's what you're dealing with. Not normal circuit breakers where the inverse time, okay? The higher the current, the quicker the trip. That's what's called inverse time, and it's proportional. This is different. This is instantaneous trip. And basically in 430.52, you have a much higher allowance or a much higher value that you can have on an instantaneous trip circuit breaker than you can on an inverse time, which is 250%. Okay. So what it says here, it says if a motor, branch circuit, short circuit, ground fault protecting device are instantaneous trip circuit breakers or motor short circuit protectors, it says the EGCs shall be sized not smaller than required by table 250.122 using the maximum permitted rating of a dual element time delay fuse selected for branch circuit, short circuit protection in accordance with 430.52C1A. So it's saying if you have those two items, either an instantaneous trip circuit breaker or a motor short circuit protector, then you're not going to, it can't be smaller than what's in table 250.22. But what you're using is the maximum permitted rating if it was, in essence, a dual element time delay fuse. Okay, and you follow what it states in 430.52C1A. That's all that is. It's not confusing. It's basically say put blinders on and forget that it's an instantaneous trip or motor short circuit protector and just pretend like it is a dual element time delay fuse and go to 430.52C1A. Boom. Okay. That's all that's saying. Don't overthink it. Don't overconfuse it. That type of scenario. And once you select that, then you can go to 250.122 and that's how you would choose your equipment grounded conductor. Okay. Makes sense? Next is G. G is dealing with flexible cords and fixture wire. It says the EGC in a flexible cord with the largest circuit conductors 10 with the largest circuit conductors 10 AWG or smaller. Okay, so this is dealing with flexible cords, and the circuit conductors are 10 and smaller. Okay, so specific size. It says, and the EGC used with fixture wire of any size in accordance with 250.5 shall not be smaller than 18 AWG copper and the circuit conductors. Okay, it says the EGC in the flexible cord with the circuit conductors larger than 10 shall be sized in accordance with 250.122. So the table. So this is just setting you some threshold limitations if you're dealing with 10 and smaller and that type of thing. Or how to deal with it when it's larger than 10 and you're just going to treat it like anything else and you're going to go to table 250.122, again, based on whatever the overcurrent protection device is. Makes sense? So that's all that is dealing with it. And I will tell you that more often than not, this is just an exercise of normalcy because when it comes to a flexible cord, if it's 10 and smaller, the manufacturer has already worked out the equipment grounded conductor size in that. So when you're 10 and smaller, it's typically going to be probably pretty close to the size anyway of the conductors that are being utilized. Not all cases, but vast majority of that. Now let's get to the big one, H. And I'll fend it off, but H is going to be the big one. This is conductors in parallel. So this is broken into what's called an H1 and an H2. The distinct difference in the two is conductors in parallel. In H1 is conductors installed in raceways, auxiliary gutters, or cable trays, and it talks about whether it's parallel conductors in one single raceway, gutter, or cable tray, just one single, or if they are in conductors are installed in multiple raceways. Okay, like two raceways, like obviously multiple raceways are more than one, so it's two or more, that type of scenario. Okay, so that's what it's dealing with. All right, so here's what it says. It says, now remember, we're talking parallel now. So we're not just talking running, 250.122A, we run a circuit to a piece of equipment. The equipment grounded conductor never has to be larger than the largest ungrounded conductor in that circuit. That's the A, that's covered. Now we're talking about a single raceway, but we have parallel conductors. So maybe I've got a trade size 4 raceway, and I've got 3 sets properly sized. Again, we're assuming that raceway fill is taken care of. We're assuming that we're not exceeding or we've made the appropriate adjustment and corrections dealing with the number of current carrying conductors and ambient temperature other than 30 degrees Celsius, 86 degrees Fahrenheit. We're assuming that's been done. Okay? Don't get into the weeds. Focus with me now. Focus. We've already done that, and now we put them in a raceway. So we have multiple sets that are being installed in one single raceway, one single cable tray, one single auxiliary gutter. You with me? So here's what it says. It says, if the circuit conductors are connected in parallel, and we're following all the rules for paralleling, right? All right, in 310.10G, okay? And again, I'm looking at 2026 edition. So they're all done in parallel properly. Same length, same characteristics, same termination, yada, yada, yada. All those things that are very important. It's extremely important to make sure you follow these paralleling rules if you're going to do that. It says, if circuit conductors are connected in parallel in the same raceway, auxiliary gutter, or cable tray, it says a single wire type conductor size in accordance with 250.122. Now, you'll notice that it does not, you with me? You'll notice that it does not send you back to the table. It sends you to 250.122 based on the overcurrent protected device for the feeder or branch circuit, okay? So that's important because it doesn't specifically send you to the table. It sends you back to the entire germane of the section, which is 122. It says, A single wire type conductor size in accordance with 250.122 based on the overcurrent protected device for the feeder or branch circuit shall be permitted as an EGC. Okay. So you can have one single conductor. Now, this isn't really much different, right? I mean, this isn't really much different than what we did up here under E for multiple circuits. Okay? Not much different. The only difference here is multiple circuits. It did multiple circuits. These are paralleled sets of the same circuit. That type of scenario, right? Not much different than that. However, if you go back and look at 250.1 and 2 in its totality, you get back to A and it says, equipment grounded conductors shall not be required to be larger than the circuit conductor supplying the equipment. Now, the problem with this here, for this one, in my opinion, is it's a single raceway now. And when it does this, and I'm installing them in parallel, I personally think that we get back to the rule that says if they're done in a single raceway, then if I have 3 sets of A, 3 sets of B, 3 sets of C, personally, you with me? And if their intent was to change this, I'm just saying, then basically if you go back to A and look at that, and it basically says, you know what, the EGC should not be required to be larger than the circuit conductor supplying the equipment. Well, if there's 3 A's, you combine them together, those are the circuit conductors. So it makes it imply, and I'm probably wrong here, and they'll be quick to tell me I'm wrong, that by doing it this way, then it's basically saying that, okay, well, in this scenario, I want a full-sized equipment grounded conductor. And it does not have to be larger than the largest ungrounded conductor, which is going to be all of the A's combined together to act as one circuit conductor. Now, they're going to say no. They're going to say, no, it doesn't have to be larger than the largest conductor in the raceway. If you go back to the beginning, that it'll say, look, it never has to be larger. Done. I get it. That's not how it could be read. I'm just throwing it out there the way it states. Now, common logic based on the direction of the code panel and the way they wanted to go with this, you could go back and say, well, okay, so they're circuit conductors. We're going to use the allowance in what's called multiple circuits. And again, it, as long as it's sized to the overcurrent device, it never, that's done. Well, that can be confusing because A says that it never needs to be larger than the largest circuit conductors. And then E says that, it's based on the largest overcurrent device, and you're going to go to the table, right? So it's going to be based on whatever the overcurrent device is. The language this needs a little more work. But they're going to tell me that no. If you have 3 sets of 1/0s, okay, because that's your minimum parallel sizing. If you have 3 sets of 1/0s for A's and 3 for B's and 3 for C's, whatnot, that the equipment ground never has to be larger than 1/0. That's what they're going to say. And that's what they say in a minute when you see multiple raceways. But it's a single raceway. That's what they're going to say. I don't think it says it that clear. If that's the direction they want to go, they need to add what we have in B2. They need to add this to this language. Because I personally think this could be misconstrued as a different way. They're going to say I'm wrong, and maybe I'm looking at it wrong. Okay, I don't know. But I know what I believe. I know what we got to this point, so it's different. Anyway, that's a single raceway. So again, you be the judge of how you think that's going to apply. But I personally think that the single wire type conductor that is to be installed in accordance with 250.122 based on the overcurrent device for the feeder shall be permitted. So if it says that it's based on the overcurrent protected device, then I think that it could possibly be larger than in the individual ungrounded conductors in that single raceway. They're going to say I'm wrong, but I'm just saying, just read how it reads. And they're going to say, no, that's not what we intended, Paul. I get it, but that's how it reads. All right, so now let's look at the second one, which is B, which is multiple raceways. Again, so these are conductors installed in multiple raceways. It says if the conductor is installed in multiple raceways, that's 2 or more, and are connected in parallel, it says the wire type EGC, if used, because it's not required, because you could use rigid, intermediate, EMT, whatever, shall be installed in each raceway, connected in parallel, and comply with the following. Number 1, it says the EGC installed in each raceway shall be sized in accordance with 250.122 based on the rating of the overcurrent protective device for the feeder or branch circuit. Gotcha. Each raceway. I'm going to go to 250.122. I'm going to size it, okay, for each circuit. Perfect. It says in 2, and this is the stuff that came up in the middle of the night. This is one of those things that got added to this without any public input. It just kind of came out of the ether during a task group. Again, I'm not going to go down that rabbit hole because it is what it is. It says it. I'm just going to go with it. It says, number 2 says, the EGC in each raceway shall not be required to be larger than the largest ungrounded conductor in the raceway. That should almost have been an exception, if you will, rather than an item 2, right? So here it says, in each raceway, it shall not be required to be larger than the largest ungrounded conductor in a raceway. So that means if I have multiple raceways, and I have parallel sets, let's say, of 1/0 in each raceway, because that's, again, parallel minimums, that my EGC never needs to be larger than the 1/0. Even if I have enough sets and enough raceways and I'm doing 4,000 amp equipment or whatever it may be, my EGC never needs to be larger than the largest ungrounded conductor. And when I ask about this, they go, well, it's just common sense. It's physics. That's bullshit, but whatever they want to say to get it, and it's in the code, and I can't change it, and it just is what it is. But it's just poor code the way it's written, and it was not justified. But if you got multiple raceways, and you put conductors in that raceway, and you've got multiple sets, and you do that in order to supply larger equipment because you can get more current out of it by doing parallel applications, then your EGC never needs to be larger than the largest ungrounded conductor in each raceway. I can promise you that's not what we agreed on in the 2023 cycle. That was not what the language we discussed. This came out of nowhere, but there it is. Now, do I think that it is muddy in H1A? Absolutely, I do. And they're going to say, no. You go back to 250.122, and it says it never needs to be larger than the circuit conductor. Well, if that's the case, why did you need to add B2 where it makes it clear that it never needs to be larger than the largest ungrounded conductor? Why wouldn't you have added that language in the single and said at the end that an EGC in the raceway is not required to be larger than the largest ungrounded conductor in the raceway if that's what you meant? That is not what's here. Let's go on to C. C says wire type equipment grounded conductors in a cable tray. So this is specific to cable tray. It says the wire type EGCs installed in cable trays shall meet the minimum requirements of 392.10b1c. Okay. Now, I will tell you what this also reminds me is that this allows me to be able to run conductors in a cable tray and be able to say, well, what is 310.31b1c all about? And that is, again, reminding you that the B1C is about the equipment grounded conductor can be insulated, covered, or bare, and it's shall not be 4 or larger. Okay, so it can't be smaller than 4. Okay. So in a cable tray, I can use a wire type equipment grounded conductor in the tray, but again, at the end of the day, it's got to be 4 or larger. Okay, and we'll assume it's still got to be sized properly anyway, but it can't be smaller than a 4. D says metal raceways, auxiliary gutters, or cable trays. It says metal raceways or auxiliary gutters complying with 250.118a or cable trays complying with 392.60b, which means they're identified and listed for grounding and bonding application, shall be permitted as EGCs. Okay, no brainer. We already get that. Next, let's move to multi-conductor cables. Multi-conductor cables, nothing has changed in here from the previous cycle except for it added the word trench in there because it made sense. That was my public input because, again, it just didn't make sense that we use the word trench in other places for an application, but we didn't use it here. It didn't make sense, right? So we added trench here where you can, put direct burial cables in a trench and run them in parallel, okay? Multi-conductor cables, by the way, is MC, AC, it's tray cable, SC cables. All these can be multi-conductor cables, okay? In non-metallic sheath cable is a multi-conductor cable, by the way, okay? Now, it says except as provided in 250.120 H2C, okay? That is when we're talking about running them in trenches, raceways, or whatnot, and you can use a single EGC to compensate for a cable that doesn't have an adequate sized equipment ground when running in parallel. That's what C is all about. So other than that provision, It just says when you're running multi-conductor cables, it says for raceways, trenches, and cable trays installations, the EGC in each multi-conductor cable shall be sized in accordance with 250.122 based on the overcurrent protective device for the feeder or branch circuit. It's a no-brainer, okay? And again, a reminder that if you did have multi-conductor cables, you would go back and follow A, B, C, D, whatnot, and follow those rules just like we did. And if it does result in, for example, increasing the size of the ungrounded conductors, you're going to have to size the equipment ground proportional. And a cable, multi-conductor cable, may not meet that. The equipment ground may not be adequately sized. If you increase the size of it, you could fall in that never land where that equipment ground is not properly sized. Manufacturers do not inherently make our cables to be run in parallel. Okay, MC cables, tray cables, no. They can be, but we don't inherently make them that way. We make the equipment ground size based on what the anticipated overcurrent protection device is for that cable itself, not a parallel application, just that cable. So when you do run them in parallel, you could run into an issue. Well, that's luckily for us, that's why we got item C here in a second, but that's the mentality from the manufacturer, okay? Now, the next one in B says, if the circumconductors of a multi-conductor cable are connected in parallel, the EGCs in each cable shall be connected in parallel. So that's following the same kind of logic of the parallel rules in 310.10, right? G, that, you know what, if you're going to run them in parallel and you're going to use multi-conductor cables in parallel, then you're going to connect them in parallel, okay? All the leg A or leg 1, all leg B, leg A, leg B, leg C. If it's three-phase, phase A, phase B, phase C, okay? All of them connected in parallel, okay? That's all that's saying. Now, C is the big one. If I go and buy a multi-conductor cable off the shelf and I want to do it in parallel and I want to install it in raceways, auxiliary gutters, or trenches, or even a cable tray, typically the equipment ground is not going to be properly sized because it was not, you're putting them in parallel so you can get a higher ampacity value. And remember, that's going to equate to the overcurrent devices, which is going to require the size of the equipment grounded conductor. So the equipment ground is already dictated by the manufacturer in that cable, so it can't make it bigger. So what this says is, okay, look, if you want to run these things in parallel in this cable tray, raceway, gutter, trench, whatever, then we're going to allow you to run a single equipment ground with it. You're going to size that based on 250.122, like how it would be normally sized based on the overcurrent device. But you're also going to combine it with the existing equipment grounds that are in those cables that are already there. So basically, at each end, you're going to connect them all together. So you're going to run an increased size EGC. It's one single cable by itself, or I should say single conductor by itself in the tray. Let's use a tray, okay? And then all of the cables that are in there with it, at each end, you're going to go to the same terminal bus. That's what we're talking about, tying them together so they act as one. Then you're okay to do that, and we will let you use the standard multi-conductor cable that you get with a undersized equipment ground for parallel application. We'll let you do it. But you got to have that single EGC that is properly sized, okay? So if you do that, that's a way to get around a standard. If you buy MC and you want to parallel it in a cable tray, and they're not going to be the size that you need, well, then you need to put them in the tray, and then you need to run a single EGC that is properly sized for whatever the overcurrent protected device is for that parallel set. Size it to that, and then make sure that it terminates on the same bus at each end so that they all act as one. Then you're in the same equipment grounding conductor bus at each end, then it'll act as one, and then you're fine. We'll let you do that. D says EGCs installed in cable trays shall meet the minimum requirements of 392.10b, 1c. Okay, we've heard that reference over and over again. So again, equipment grounds can't, 4 and larger. You can't be smaller than 4. It says cable trays complying with 392.60b, that would be those that are listed and evaluated for grounding and bonding application, are to be used as an equipment ground. It says metal raceways complying with 250.118 or auxiliary gutters shall be permitted as EGCs. Again, that is 250.118a are metal raceways like rigid metal, intermediate metal, EMT, all those are listed as an equipment grounded conductor. Auxiliary gutters are permitted. Again, we're marked from the manufacturer as suitable as an equipment grounded conductor. And of course, cable trays that meet the requirements of 392.60b that are used as an equipment grounded conductor or are marked as such can be used, and then you don't have to worry about any wires, okay, that they're already okay to be used, okay? Lastly, feeder taps. So when it comes to equipment grounded conductors for feeder tap applications, so you've got a feeder that's running out from a panel, you're going to be tapping from that feeder, and you know we have tap rules, 240.21 tap rules, right? It says the EGCs installed with feeder taps shall not be smaller than shown in 250.122 based on the rating of the overcurrent device ahead of the feeder on the supply side ahead of the tap. Obviously, you have an overcurrent device at the point where it gets its source, and then the conductors go out from there, and you're going to be tapping those feeders, okay? Tapping those feeders. So this is saying, look, I want to make sure that that feeder tap typically is going to be based on the size of the feeder's overcurrent protected device. Makes sense? Whatever that feeder is, overcurrent device, you go to table 250.122, boom, bing, bang, boom, done. However, it says the rating of occurrence ahead of the feeder on the supply side ahead of the tap, but it says but, there's a big but here, it says but shall not be required to be larger than the tap conductors. So most engineers will say, look, if I'm going to take a feeder and I'm tapping it and I'm following all the tap rules, if by chance the overcurrent protected device obviously is going to be larger than the conductors that are tapping, because that's the whole concept of a tap rule. So from that tap down to whatever I'm tapping down to for a piece of equipment, we don't want a situation where that equipment grounded conductor is going to be grossly larger than those tap conductors, is what it's saying. And it could be, because obviously those conductors are going to be less ampacity than the feeder that it's tapping. That's the whole purpose of the tap rule, right? If they were the same size and you tapped it, then they wouldn't be tap conductors. They'd just be an extension of that feeder, right? Makes sense? So tapping it by true nature, those conductors that are tapping that feeder are going to be less ampacity as long as they're meeting the tap rules. And so this is just saying, you know what, there's no sense in you having to come off of that with an equipment ground that's based on the overcurrent device as long as it's, not required to be larger than those tap conductors. Okay, so if I'm tapping it with a 6, then my EGC would not have to be larger than a 6 with those tap conductors. Even if the overcurrent device for that feeder would have dictated a larger type of EGC. It doesn't have to be larger as long as it's going with the tap conductors. Get me? Okay. Anyway, that's enough for that today, folks. Hopefully you got something out of that. That just kind of explains what's going on in the 2026 edition. I think that it's still in my mind. And people that are in the code say, no, it's clear now, Paul. It's easy now. But when we added that B2, it says it never need to be larger, then it really screws up the fact that 250.122A and the reference to that in a single raceway still references 250.122, that you could have a plausible situation where when you run parallel sets, even if it's in a single raceway, and you tie the ends together, they act as one circuit. And if you go back and look at A, it says the EGC shall not be required to be larger than the circuit conductors, plural, supplying the equipment. So again, I will submit that if I have a piece of equipment and I'm running parallel sets of A, B, and C to this large piece of equipment, that if I'm not running parallel raceways, I'm just running one single raceway with all of these in it, then I would argue that it's clear that you could have an equipment grounded conductor that is larger than any single ungrounded conductor, but not larger than the set. You with me? All of the A's, circular mills added up, that is now the circuit conductors that are supplying the equipment, because we're doing it in parallel. Does that make sense? Does that make you go, what the hell? Anyway, hopefully, folks, if you want to learn more about the National Electrical Code, check us out on our website, fasttracksystem.com. Check it out. Learn all about the National Electrical Code. We'd love to get you into the family, help you learn the NEC. If you have any questions, you can also go to paulabernathy.com. If you want to reference this episode, I don't remember the number. I think this is episode 36. I can't remember. But make sure you give me a little summary of the episode and your question, and I'll be more than happy to answer it. Till next time, folks, stay safe. God bless. We'll catch you on the other side.
Thanks for tuning into another electrifying episode of the Master the NEC podcast. We hope you're feeling more powered up and ready to tackle the electrical world with the knowledge and confidence you need to succeed. Remember, in the electrical trade, knowledge is power, and we're here to make sure you stay plugged into the latest insights, tips, and code updates. If you enjoyed today's episode, don't forget to subscribe, leave us a review, and share the podcast with your fellow electricians and industry pros. Until next time, keep your tools sharp, your circuits clear, and your mind focused, because here at the Master the NEC podcast, we're all about sparking your success. Stay safe, stay smart, and keep mastering the trade. From all of us here at Electrical Code Academy, thank you for all your support, and we will see you on the next amazing Master the NEC podcast episode.